Alright, this is a video for lab 6, and let's see, this is for the bending stress calculation. So the bending stress in this part, we have a moment from the 10-pound force. So it's a moment about the axis out of the plane. Okay, so if you Google it, and that'll be something like this one, and you have a stress on the top and a stress at the bottom. The top would be in tension and the bottom is in compression, so that the top red is tension, bottom is compression, and that's the equation. And please note, it's not necessarily x direction. Okay. All right, so that's the background, this knowledge of the bending stress. Then how do we get the bending stress from hand calculation as well as from NX? So first, let's get the start from the hand calculation. And so to know the bending stress, let's see if we still have that, you would need to know the I, and that I is moment of area, or moment, yeah, it's called moment of area. So it's related to the cross section of the beam, and here it's a sort of like a C-shaped beam. And how do we get that? We need to measure that from the model, then let NX do the job to calculate the I for you. So what you need to do is first find the cross section. So to find the cross section, we need to go to the idealized part. Because remember, we have the section option in the fan, and if you want to see the section in the fan, first you need to create a section for your fan. So here's the handle, and we're gonna make a cut. Just made a cut along this arc, then just the old split body. Okay, so pick the body, and we need a plane to cut this. We need a plane that goes through this arc. So you would pick through object, and the object is this edge. So you want to make sure you pick this edge, and that'll be your cutting plane. Say OK, and you notice this cuts goes all the way to the other side, and the other handle doesn't have this line here. Okay. All right. Then if you go back to the fan, which it's not loaded yet, so I have to go back to the sim and open the fan. So let's turn off the nodal displacement, nodal display, and we don't need the fan part, just need the polygon. Alright, so that's the cross section. Okay, that's what we did here. Then you get the cross section. Then how do we get the property out of this cross section? We use this 1D element section tool, and that's actually, if you turn it on, it's what we did for the pins. You have those diameter for the pins. So we needed to create a new section. However, this time it's not those regular shape. It's face of the solid. So that's this face. So we'll pick this face. And the second thing is you have to pick an axis for the face, which is actually the axis here, Y or Z axis. Okay, so you can either define the horizontal or the vertical for this geometry. That'll determine which direction is Y, which direction is Z. So we'll just go default, define the horizontal one. We want the horizontal go from the bottom, okay, this direction. So it knows this is the horizontal, then your vertical is this way. Then you can take a look by clicking that preview button, and you can zoom in, zoom out here. Now you want to take a screenshot of this, so you know which point is which, and which point is the location of each point. So you have C on the top and D at the bottom. Then if you look at the bending stress here, can we zoom in a little bit? Alright, you have a point on the top, a point at the bottom. Then the distance from the points to the neutral plane, that's the y you will need for the equation. The y is the distance to the neutral axis. Then so where are the distance? Then you just click this evaluate section, and that'll give you the centroid. The centroid is this point. That's your neutral axis. So if you look at the coordinate system here, y is vertical, so the centroid on y direction is minus 0.37 from the origin to this point. Okay. Then you also want to know this y coordinates of C, which is here. Okay, so C is 0.13 below the origin. Then you can calculate the distance from C to the neutral plane. That's your y in that equation. This my divided by I. So the I is here, moment of inertia. It's actually a moment of area, and which one you have to choose? It's actually IZ in my case, because the rotation is about the axis in this picture. Notice that Z and Y has nothing to do with the absolute coordinate system or the absolute Y or Z in the model. It's just for this section. You consider this as a sketch. It's not related to your model. Okay, so the bending is about Z-axis here. Then you need the moment of inertia on Z direction. So IZ is the one you have to use. Then so you have I, and you can calculate Y from the coordinates of the centroid and the point C, as well as point D. Then you get the distance from C to neutral, from neutral to D. Those are the two distances you will need to calculate the stress. Okay, so that's actually for this equation, and you have to do this twice for point C and the point D. Then you get the stress on the top and the bottom. Then that's your hand calculation. Then we need to get the stress out of NX, which is in the sim. And by the way, this step, it's just purely using NX to calculate the property. Okay, sure, you can calculate it yourself, but that's too much work. So you don't have to save this. Once you get the information you need, you can shut that down. Anyway, then the stress from NX, we will need stress element nodal, and it's sort of on the y direction, even though it's not exactly on y direction. Okay. Then remember, for stress you have to show just one piece, otherwise the stress will be flooded by other meshes. So not this one, I would like to show the other one, because this one is more aligned to y direction. So, and you gotta be careful which point you pick. Okay, and maybe before you come here, you can take a look on your model where the cut is. So in this case, my cut here is 2 grades down from the triangle element, right? So I would pick the point here, that's the triangle. I will investigate this point. That's 2 grades down from the triangle. So this will be 3800, And if you use that maximum, it's actually about 200 more. Okay, so that's for that point. And for another point at the bottom, which is in compression, 2 grades down along this line here, so that's about this point. And those are the stress from NX. Then once you get those 2 values from NX compared to the 2 stresses from this Hanna calculation, you can have some percentage error. And be careful, this one will be a little bit off, maybe 20%. So it's okay. This is not really very accurate. The section, the distance of the force. So we talk about the distance of the force. The M moment is 10 pounds times the distance to your cross section. So the distance, perpendicular distance to the section is here. You can use this distance or you can measure it yourself. Then the force is not perpendicular to this distance. It's actually about 90 degrees off. So you need to, if you need to be accurate, you need to find the component on that direction, the perpendicular direction to the distance. Or also it's parallel to the section. That's why I was measuring from the section to the force. That's the distance. That's the angle between them. So it's actually not that much because it's cosine 90 degrees. It's about close to 1. So that's your moment for this equation. You have the moment, and you have y. You can get I from NX. That's all you need. So that's how we calculate the stress on the handle. Alright, so hope you can find a good results.